In this video, we're going to talk about scientific notation. Now, scientists often deal with numbers that are extremely large or really small. So some examples of large numbers would be like the number of stars in the universe, which is estimated to be 200 sextillion stars, or the number of cells in the human body, roughly 35 trillion, or the mass of the sun in kilograms, this really large number here. Now we also have really tiny numbers like the mass of an electron in kilograms, this small number, or the wavelength of blue light in meters, so that's 475 nanometers. Now, each of these numbers is a bit tricky to have to write. It's kind of a pain to have to write a big, long number with all these zeros. And can you imagine writing a scientific paper where you had to keep referring to the mass of an electron and you had to keep writing this number out with all these zeros, making sure you had the exact correct number of zeros without making any typos? That's a bit of a pain. So scientific notation is a way of expressing numbers that are too large or too small to be conveniently written in standard or decimal form. Now, a number is said to be expressed in scientific notation if it has the form a times 10 to the n, where a is a number between 1 and 10, so a is greater than or equal to 1 and less than 10, and n is an integer or a whole number. Okay, let's look at an example. So question, is 875 times 10 to the sixth power in scientific notation? Now, it looks like it has this form up here where the n is 6, and the a is 875, but the problem is the 875, the a is not between 1 and 10. We need a number between 1 and 10. Now, we'll talk about how you convert back and forth between standard notation and scientific notation, but it turns out this number we'd have to write as 8.75 times not 10 to the 6th, but 10 to the 8th power. Okay, and that would be written in scientific notation. Okay, but before we can talk about how you convert back and forth between scientific notation and standard notation, we want to understand a certain principle. So what happens when you multiply a number by, say, 10 to the third power or 1,000? Okay, let's take a number like 4 and multiply it by 1,000, and notice, of course, what we get is 4,000. So we ended up adding 3 zeros onto the end. Another way to think about it is we have a 4 with a decimal place after it, 4.000000, and we move the decimal to the right 3 places, so we ended up adding 3 zeros onto the end here. Now, when we take a number like 7.51 times 10 to the third, we're not, of course, going to add 3 zeros. What we're going to do is move the decimal 3 places, so we'll get 7510. So again, this decimal moved 1, 2, and we move it 1 more, we have to add a 0, we get 7,510. So notice that multiplying by 10 to the n, where n is a positive number, moves the decimal to the right by n, and we usually end up having to add some zeros onto the end. Okay, we'll talk about what happens when n is negative in just a second, but let's do an example. Suppose we want to convert 6.28 times 10 to the 7th to standard form or decimal form. Okay, this number is in scientific notation, so how do we do this? Well, we need to move the decimal place to the right 7 places, and we have to move it to the right 2 places to get past the 8 here, and we have to add 5 more zeros onto the end. Okay, so what we get is 6, 2, 8, and now we have to add 5 zeros, 1, 2, 3, 4, 5. And now we can put in our commas. So this number is really 62,800,000. So notice we ended up moving the decimal place 7 times. We had to move it twice to get past the 8, and then 5 more. So a total of 7 places the decimal moved. Okay, now what if we're given a number in standard notation, like 54,000, we want to write it in scientific notation? Well, notice we're going to need 5.4. We need this number a between 1 and 10, so 5.4 will do. Now, how many decimal places do we have to move the decimal? Well, from 54,000 to 5.4, the decimal moves 1, 2, 3, 4 places. So this is 5.4 times 10 to the 4th power. Okay, really 5.4 times 10,000. That's what 10 to the 4th power is. Okay, now let's recall our large numbers. We have the number of stars in the universe, which is 200 sextillion. Well, it turns out in scientific notation, that's just 2 times 10 to the 23rd. Notice that's so much simpler to write than a 2 with all these zeros after it. Same thing with the number of cells in the body or the mass of the sun. These numbers are so much easier to write than these numbers over here, right? So you can see the utility of using scientific notation. Okay, now what about when n is negative? So what happens when you multiply a number by, say, 10 to the negative third power? Well, 10 to the negative third is the same thing as 1 over 10 to the positive third. That's just a property of exponents. Or 1 over 1,000, or 0.001. So what happens when we take a number like 7 and multiply it by 10 to the negative third, or multiply it by 1/1000th? Well, of course, we're going to get 7 1,000ths. Right? It's 0.007 or 0.007. Okay, and notice in this case, the decimal, which initially began here, actually moved to the left 3 places. So when you multiply by 10 to the negative third, the decimal moves to the left 3. So we have to move 1 time to get to the left of the 7, then 2 more times to get over here. So we end up adding 2 zeros there. Okay, let's do an example. Convert 3.8 times 10 to the negative 5th to decimal notation. Well, again, we'll have to move the decimal to the left 5 places. But we moved it to the left 1 to get past the 3, then 4 more places. So our number is going to be 0.0000, so 4 zeros, 38. Okay, and we can add the 0 before this here. So this is the number in standard or decimal notation. Now, if we want to go the other way around, if we want to convert to scientific notation from decimal notation, how do we do that? Well, in this case, notice that our first non-zero number here is 5, so we're going to put 5.892, 5.892. And then how many decimal places does the decimal move from 5.892 to 0.000005.892? Well, it goes 1, 2, 3, 4, 5, 6. So this is 5.892 times 10 to the negative 6th power. And notice when you have 10 to a negative power, that's when you're dealing with these tiny numbers, 0.0000 something. When you have 10 to a positive number, that's when you're dealing with the big numbers. Okay, so this is the number in scientific notation. And again, recall our tiny numbers, like the mass of an electron. Notice this is much simpler to write the mass of an electron like this. You don't have to keep track of how many zeros you're typing out. It's just 9.1 times 10 to the negative 31st power. So again, we see the utility of scientific notation. Okay, now one last thing. How do you multiply numbers that are written in scientific notation? Well, it's actually pretty simple here. Notice that multiplying this number in scientific notation times this number in scientific notation ends up really being multiplying 4 numbers together. Okay, and multiplication is both associative and commutative. So what that means is we can multiply these numbers in any order that we want. So we can rewrite this as 5 times 9 times 10 to the 7th times 10 to the 11th power. And that can be rewritten as 45 times 10 to the, 10 to the 7th times 10 to the 11th would be 10 to the 18th. And we're almost done, but that's not in scientific notation because 45 is not between 1 and 10. So we need to rewrite this as 4.5 times 10 to the, it'd be 10 to the 19th now. Okay, so that's written in scientific notation.